We have a few more people joining us for this one. Awesome. Thank you all for being here. I'd like to introduce your next speaker. Javier Portilla-Edo is a test automation engineer with VoiceFlow, and whenever you're ready, you can go ahead and take it away.
Thank you. So let's get started. So today in this talk, we are going to talk about Alexa skills and Kubernetes. So, but first of all, let me introduce myself. I am Javier Portilla-Edo. You can follow me on all my social media accounts, Twitter, GitHub, YouTube, or Twitch at Shavidop. I am organizer of the DevOps Days Madrid too. As Molly said, I am working as a test automation engineer in VoiceFlow. I love all the Alexa related stuff, and I was working in the Hyperloop project during 2 summers at the SpaceX headquarters. Sorry. And if you want to learn more about me and about all my contributions to the Alexa world, you can just go to my personal blog site, and which is shavidop.me, and that's it. As I've been awarded last summer as Azure Content Hero due to my contributions to the Microsoft Azure world. So today we're going to talk about the Alexa skill. What is an Alexa skill? An Alexa skill is just voice apps that are running on the Alexa devices, the Alexa enabled devices like the Amazon Echo Show or the Echo Dot devices. So there are applications that they have like the same behavior as a chatbot, but the input is the voice instead of the text. So that's why when Amazon introduces the Alexa skill concepts, or the Google and Google Assistant introduce the Google Actions concepts, it will start a new job called the voice app developer. So so I am a voice app developer in my free time. So the Alexa skill has 2 main parts. The main part is the voice user interface, the GUI. This is the main interaction using the voice. And then we have the Alexa presentation language, which is for all the devices that has built in a screen, like the Echo Show 5, 8, or 10, or the Fire TV stick. So in terms of the architecture, in terms of how Alexa works, when we start talking to an Alexa device, the Echo will start hitting us, and then when we stop talking, all the voice, all the sound will be sent directly to the Alexa cloud. The Alexa cloud, Alexa itself is another AWS service, and there in the Alexa cloud we will have automatic speech recognition, and we will have a natural language processing there. So after that, the Alexa cloud will transform all the voice input as a JSON, and then the JSON will go to a backend. So the backend will get the resolution, will get the response, and then that response we will send to the Alexa cloud services in JSON as well, and then the Alexa cloud will use the text to speech, the TTS, to transform the JSON that we have, that we reply as a JSON into voice, and then the Alexa device will speak all the things that we have found in the backend. So yeah, actually the architecture, or well, the recommended architecture is this one. In terms of the backend, the everything is ready to work as an. I mean, the backend is everything to work as a AWS Lambda. So that makes sense because it will executes only when the user requests for everything. So that makes sense to not to have like a server every time running. So yeah, the code is running as AWS Lambda. Then we have the AWS CloudWatch to see all the logs for the Lambda. Then we have AWS S3 to have all the assets, the media assets like images, like sounds, like videos. Everything will be on the AWS S3. And then for persist the databases, we have AWS DynamoDB. So yeah, and in all the backend code, in terms of the Lambda, we have the Alexa skill kit to build that backend. So the Alexa skill kit is available in Node.js, Java, Python, or .NET. And then there are another unofficial backends, which is the .NET. I told the .NET, but this is not official. And then we have another backends like Azure Functions or Heroku. You can deploy there. But the recommended one is the AWS Lambda. So, but what happened if we want to host it on Kubernetes, the full backend stuff? There will be multiple purposes or multiple ways or multiple decisions that we have to move all our backend into a Kubernetes cluster. For example, imagine that you are working for a health company, like a health insurance company, and you have everything in your availability zone, or you have everything in your data centers. So you want to retrieve all the data only inside your cluster. So that's why, for example, a good example to have the backend running on the Kubernetes, because it's the only way to access the data, for example. So for that, we have to need some transformations, because as I told you, we have the standard architecture is based on AWS Lambda, but if we are going to move to the Kubernetes cluster, we have to change a lot of things in our backend code. So the current situation about the Alexa and Kubernetes is like we are in the starting point. I think I am the first person that have made this up and running. There are a lot of work, and there's a little bit of lack of documentation. So in this example, we are going to use Azure Kubernetes Service, the AKS, but I have the example for Google Kubernetes Service and for the AWS too. So this is the architecture running it on a Kubernetes cluster. So as you can see here, the left side is exactly the same. I mean, the user will interact with the Alexa device, then all the voice will go through the Alexa cloud, and then the Alexa cloud will send the request to our Kubernetes cluster. In a Kubernetes cluster, we are going to have an Nginx controller. So that will works as a load balancer. That request will go through our Node.js application, and then the data will be for the persistence of our Alexa skill will be in the MongoDB. everything is packaged as a Helm chart and deployed in a Kubernetes cluster. The other solution that my solution accepts to is having exactly the same architecture, but it's instead of running in your Kubernetes cluster a MongoDB instance, getting and storing data directly in MongoDB Atlas, in Mongo Cloud. So yeah, this is all the changes that we have to do before start like interacting with our Alexa skill running on Kubernetes. So the first step is create a web server. I mean, we have to transform the Lambda code into a web server one. Then we have to Dockerize that web server. Then we have to create a MongoDB adapter, because if you remember, all the adapter are for DynamoDB, and then we have to create the MongoDB one. Then we have to encapsulate everything in a Kubernetes object ready to deploy. Then we have to create a Helm chart in order to deploy everything into multiple clouds or multiple environments. And then we have to deploy the Alexa skill, because the backend is already deployed. Oh, sorry, deploy the Alexa skill, then deploy the Alexa skill backend on AKS, and then testing. Then we can just publish our Alexa skill into the Alexa skill store. So yeah, the first thing that we have to do is create a web server. So the Amazon Alexa team has a Node.js package called ASK, which is the Alexa Skill Kit SDK Express Adapter, which is an NPM dependency, and the code is similar to the Lambda approach. So with that, we can transform, as you can see in the next slide, this is the Lambda code. The left one is the Lambda code, and then in the right side, you will see the code transform as an Node.js Express server. So as you can see, the core of the lines of the code are exactly the same, except that instead of calling the Lambda method, we will call and we will set up the Express server using the SDK Express adapter. So that's so easy. This step is the most easiest one, sorry. And then, as I told you, the Alexa team has the SDK officially launched on Python, Java, and JavaScript. So we can create web servers for Java and Kotlin using Spring Boot, or because there are adapters to do that. And then there are adapters for Python to transform Python Lambda to run it as a Django web server or Flask web server. After that, we are ready to Dockerize our web server. This is just creating the Docker that will run our Node.js Express server, which will execute the full code in our Lambda. And then what happened with the database? Because actually the adapter that we have, the official one, only works with DynamoDB. But this is so easy because we are going to build the MongoDB persistence adapter. I've already built that, so you can check it on my GitHub. My user is Shavidop. So yeah, you have to implement the persistence adapter class, which is available on the Alexa Skill Kit SDK core. And as we are going to build our backend in Node.js, I built that on JavaScript or TypeScript library. So if you have your backend on Python or Java or Kotlin, you can write the same. Just you have to implement the persistence adapter. The persistence adapter is just like an interface that has 4 main methods, which is the get persistence attribute to retrieve the information, set persistent attributes to set the new information, the save persistent attributes is just to flash directly to database, like saving in the database all the information, and then the delete persistent attributes to remove the information directly on the database. So just implementing the persistence adapter interface, you will be able to build your own database adapters, and everything will be ready to work with an Alexa skill. So yeah, as you can see, in 4 lines of code, you can have a MongoDB adapter running, and then all the NoSQL, or the main important ones in the nowadays, like Redis, Couchbase, like CosmoDB from Azure, or the Firebase. Using or implementing that adapter interface, you can build easily database adapters for that. So yeah, after that, actually we have our adapter, we have our Node.js web server, and then we have that web server Dockerized. So we are ready to create our Kubernetes objects to deploy it on a Kubernetes cluster. So this is the architecture that we are going to follow. This is the main one. So we are going to have as an ingress the engines, the Kubernetes ingress controller, that will be act as an ingress and as a load balancer too. So all the requests from the Alexa Cloud service will go through the engines ingress controller, and then will go directly to the Node.js web server application deployed on Kubernetes. And that Express server, which will run in a pod, will be interact with the MongoDB, which will be running either or another pod, or accessing to the MongoDB Atlas Cloud. So yeah, when we create the Kubernetes objects, we have to transform all that Kubernetes objects into a templates in order to use it and to package everything as a Helm chart that allow us to deploy everything to all the environments that we want. Like if we want to deploy it in a bare metal cluster, or AWS cluster, Azure or Google cluster, or just in a kind cluster in our local development stack. So with that, transforming like our Kubernetes objects into templates in order to be able to deploy it everywhere. This is the next step, just creating the Helm chart. Like that will be one of the main artifacts that we have. And then when we create the Helm chart, the only thing that we have to do is just deploy it. So deploying it is just, for this example, I use Terraform. So Terraform is infrastructure as a code. So all the scripts in my GitHub, you will find the Terraform scripts to deploy everything in Google, Azure, or AWS Kubernetes cluster. So the first thing that we will deploy is the Kubernetes cluster itself. We are going to create the cluster, in this case the AKS. Then we are going to deploy the engine ingress controller, and then deploy the load balancer depending on the cloud vendor. Then if we want to deploy the MongoDB, there is a values, which is a toggle that enables or disables the Helm chart easily. And then we are going to deploy the Helm chart of our Alexa backend Express web server. And what about the local development? Because now it's not so easy to deploy everything or to develop everything locally, because we have like a mix of local stack and cloud stack and that kind of things. So for the local development, I am using currently devspace.sh, which is a platform that allows you to create a tunnel between the Kubernetes cluster and your local process. So with that, you can develop easily in your IDE, like for example Visual Studio Code. And when you change some files, when you change some configurations, the dev space will be automatically listening for that changes and will be redeploying all your changes into the Kubernetes cluster. So it is cloud agnostic. I mean, it will use only your current context. So if you are pointing to your local machine using a kind cluster, you will redeploy it into the kind cluster. But if you are pointing to a Kubernetes cluster on AWS, for instance, it will be run exactly the same. So you have to specify a dev space YAML configuration, because you have to specify what to deploy, where to listen, and where are the paths to see and to check when the auto reload is needed. So here, this is the YAML configuration. The first thing here is we have the images, which is located on my GitHub code down docker/docker file. There is a docker file. You can override the entry point of that docker file, and then you have to specify the deployment. As I told you before, we have created a Helm chart, so you have to specify your local Helm chart definition, and then you will set the image that you have built in your previous step, and then you will set up the auto reload and the sync paths, and after that everything is synchronized. We will see in our dev space we have a web interface. So if you go to that web interface, you will be able to see all the pods that are running, and by clicking there you will see all the logs, or you will be able to run a Kubernetes shell in your browser, accessing to that to the Alexa skill. So I think that's it. Thanks for joining this session. As you can see, as a conclusion, there are multiple solutions for the Alexa backend. There are multiple databases. The delay in the response will be increased due to the architecture is more complex. That's obvious. And at the end, you will have the same result, but with different approach. So yes, a little bit of just to sum up, to finishing with some recommendations. You can follow me on my social media accounts at Xavidop. You can find more about me on my blog site, xavidop.me. And if you have any question, just ping me on Twitter. I have opened my DMs. I recommend to you to follow as well the Alexa developers official accounts in Twitter, Twitch, or YouTube at Alexa Devs. And if you talk or you understand the Spanish, I've written the first Spanish book about Alexa development called La Revolución de Alexa, which means the Alexa Revolution. So this is a from zero to hero course of 500 pages, 18 chapters, just about Alexa skill development. So thank you all. If you have any questions, I can answer it here, or if you have questions, you can ask me on Twitter. So thank you for tuning this session. Thank you to Developer Week Europe to bring me this opportunity to be here talking. And yeah, that's it. Thank you, everyone, and see you.